And this figure shows a single turn. Oh, single turn means n equals to 1, as you know. And this is a rectangular coil, as you can see in the figure. Yeah. That has a resistance R. So this is R, resistance R, 2 ohms. The magnetic field at all points inside the coil. You can see that these blue X's here represent the direction of the magnetic field. So the magnetic field is going inside, okay, inside, coming from outside the screen, inside the screen, okay. The coil varies according. Oh, so that means the magnetic field is changing. It is not uniform. It's changing, and actually it is. Does it increase or is it decrease? As you can see, it is. Yes, it is decaying. Why is that? Because this is B equals to B naught e to minus alpha t. So this is a natural exponential, okay, a function, as you can see, and it's actually with a minus sign there at the top there. So this is why this is actually decreasing, okay? So this is decreasing or decaying, okay? And because that one at the power there, so this is why the decreasing is very fast. Okay? B naught is 2.25 Tesla, alpha is 200 hertz, and this is actually obvious because we know that hertz means 1 over s, and we have t there at the top. So alpha 1 over s, which is hertz, into s, s will go with s. So we have only numbers at the top there. What is the magnitude and direction of the current induced in the coil? Okay, so they are looking for the current induced in the coil. So, okay, at 3 different times. After a very short time, 0.001 second, which is just a fraction of 1,000, and then 2 fractions of 1,000, and then after 2 seconds, after a long time, little bit long time. Okay, so how can we get the I induced? So the question is, what is the, so what is the I induced? So this is the question. Actually, to get I induced, okay, you know the story. I induced is coming from epsilon induced. Okay? And to get epsilon induced, you know that you have to take care about the change in the flux. Yes, you are right. Okay? So relating these 3 together, you can find one by one. Okay, so step by step. So let's first of all take the condition A, where the time that they have been asked us to find is just a fraction of 1,000. Okay, at t equals to 0.001 second. Okay, what is the induced current there? Okay. So we'll start from the this equation, which is the induced, okay, epsilon equals to minus n, don't forget the minus sign, delta phi over delta t. Yes, all right. Excellent. Okay. Now we know that this is delta phi over delta t, and we know actually delta phi depends on shabab, on the magnetic field. Yeah, we know that. So in this case, we have to look for phi actually before we start with that one. But because we have delta phi and delta t, so this is the first derivative of delta phi. So that means it would be the first derivative of b into a. Okay, so we know that this is b into a. So b into a in general, okay, over delta t. We know that one. Actually, n is 1. In this case, n is 1 because it has been given a single term here. Okay, so n equals to 1. Okay, so there is no n here, but there is a minus sign, so we have to keep the minus sign there. Okay, now what is changing؟ يعني ايش اللي راح يتغير الحين؟ ايش اللي صار الديكي كما اتفقنا؟ هو البي. Okay, but a is constant because a is this actually this area here. Okay, so a is not changing. Okay, and because a is not changing but b is changing, this is why we have flux changing. Okay, so flux changing, as you know, is related to due to one of these two, or maybe both of them. يعني في بعض الأحيان نحصل إنه the magnetic field والarea they are changing together, but in our case now we have only the magnetic field is changing. So let's write down that, again that one down. But before that, we know that a is constant, so let's write a is constant, which is outside now. Okay, and then we are integrating sorry, we are differentiating now. So this is will be delta B not e to minus alpha t, okay, with respect to t. Okay, but we know again that B naught is constant. Why is B naught is constant? Because B naught is just the maximum amount of the magnetic field. Okay, so we can take B naught also out here. Okay, so this is again to be minus sign. So let's forget the minus sign. A into B naught, because that is a constant. And now we are left only with that minus exponential function. Okay, so we want to get the first derivative of that one. And I will give you a little bit here, a very fast mathematical and physical actually hint that can also refresh your mind. Why we are using e to something here? Why we are using this very famous exponential function, actually, or natural exponential function? Because this is a very useful actually in physics. Okay? In physics, instead of, because we have many kind of waves, you know, so we have sound waves, okay, we have the light waves, we have different kind of waves coming from different sources. So in physics, instead of writing cosines and sines, okay, maybe you know this is Jx equals to cosine x, okay, plus j, which is the imaginary part, sine x. You see this is small e to something, it is actually representing a physical meaning. And the physical meaning is describe the wave. You see, you know the cosine of the wave, that continuous wave that is going with the crust, okay? And this all motion of that waves is described by e to j of x. So this is actually the imaginary part and this is the real part, okay? These details are not important. هذا كله ما مهم, okay? فقط لمعلوماتكم هذا, okay? ايش المهم? Why is that again? Why we still use e to something? يقول like, because it is very easy to get the first derivative or to get any differentiation of this kind of function. Okay, so e to j to x with respect to x in this case, because x is varying, هذا بيكون نفسه e to j to x. Okay, يعني هذه قاعده لازم تاخذوها مضروبه طبعا يا شباب في يسميه x derivative اللي هي chain rule. Okay, فكأنه يعني فوق عندنا function صغيرة. Okay. أول ما نعمل first derivative of e to something, so we know that is with respect to x, one of that something. Okay. So then it will become the same thing, نفس الشيء بتكون هي نفسها, but multiply with the function of that one. فإن our case خلينا نقول e to مثالنا حتى ما نروح بعيد. Okay. e to alpha t. Okay. So the first derivative, if this is y, okay. So y dash نسميه اللي هي اسمه دلتا e respect to t. يعني first derivative of this it will be يا شباب, خلينا ما نرصها مع بعض حتى تشوفوها بشكل واضح. Okay. So the first derivative equals to delta e alpha t, okay, with respect to delta t. This is will be يا شباب again the same thing directly but into alpha. Okay. Why is that? Because the first derivative of this one, يعني لو خذينا alpha t وحدها as a function, the first derivative of that from the calculus, I think this is something you know, so that will becomes this is will go مثلا نقول 5 س ثانويه, okay, فراح تروح السين تبقى الخمسه because بنشتق احنا لسين, فنفس الشيء it will remain alpha here. Okay, at the end of the day we have the answer alpha e to alpha t. طيب لو واحد قال لي if there is a minus sign, إذا قال لي واحد there is a minus sign there, أقول له أيوة you have to take care about that minus sign, and alpha هنا بتكون minus يا شباب, فاهمين معي؟ هنا أيضا بتكون minus. نفس الشيء راح نطبقه هنا. Why I go to explain these details? Because I need you to also to ask yourself why we have this kind of function. It has a really very important physics, يعني quantum physics احنا ما نستغنى عن كثير من هذه الfunctions. Okay. Okay, so minus sign a b naught. What is the derivative of e to minus alpha t? So this is minus alpha t. Okay, so minus alpha t. The first derivative of that, it will be like e to minus alpha t into minus alpha. Okay. And because we have minus sign, this will be positive alpha into a b naught e to alpha t. Everything is known for us because we know alpha is 200. We know B is 0.25 Tesla. We know the area, which is 5 centimeter into 2 centimeter. We should make this one in meters. Don't forget to do that. And then you can get your result very easy at the chosen time. The time is, Shabab, 0.001 second. Okay. So now we can answer actually all of these times. يعني احنا ممكن الحين نعوض على ال A, B, C كامل يعني. طيب لما يكون A at time equals to 0.01 seconds, this will gives me I, if you calculate it very well, 20 milliampere. Okay. B, when time increase little bit, and what is the physics behind this? Okay. This will gives me I, in this case, 16. Oh, the reduction is huge. Milliampere. Yani we are just letting another fraction of 1,000 of that second, little bit. Yani we just weigh that fraction and then we see the current reduced by more than 3.3 milliampere. Okay. طيب after t equals to 2 seconds. Okay, so 2 seconds is too large. Okay. In this case, it will be خلينا نعوض عنها. It will be I equals to 0.025 Tesla, which is the maximum, e to minus 200 into 2. 200 into 2, that means 400. And this is a very large negative number. So this is why this is like almost very near to 0. So I, in this case, equals to 0 ampere. Okay. Almost. Okay. Why is that? Because it will be very tiny number. وهذا حقيقة in physics, from physics, it is really something that we can feel, because if we have an exponential negative number and then there is no magnetic field, so there is no that much flux. Okay, so that means there is no induced epsilon, so that means there is no induced current.